Hello there, everyone. Welcome back to Java Made Easy by Roy, your host. Today we're going to talk about linked lists in Java. So I'm going to talk about what linked lists are, and I'm going to tell you about the pros and cons to using linked lists as opposed to array list. I'm also going to talk about some methods that you can use to manipulate linked lists and so forth. So with all that, let's get started. So what are linked lists? Well, linked lists are linear structures where the elements are not stored in contiguous location, meaning these elements are not overlapping each other like they would be in an array list, a vector, a list, and so forth. So they're spread out in memory, and every element is a separate object with data and is referred to a node. Now, these nodes are linked using pointers and memory addresses. So, as I alluded to earlier, they're all scattered in memory. I'm going to give you an example here of three different nodes. So here we have, here's our head node, and here we have the address of 400. So the previous address is 0, but the next address is 600. So we follow along and we look for the next node in the memory address of 600, and here we find the next element, 5. So as you can see here, it's doubly linked because it has the 400, which is the reference to the previous node, right? And we have 800, which is the reference to the next node and which contains the number 7. So far we have 1, 5, and 7. So these are linked by these memory addresses, but not linked physically because they're all scattered out in memory. Okay? I hope that made sense. And now I'm going to talk about what the differences are between linked lists and array lists. So an array list is a dynamic array, right? And essentially it stores elements in a dynamic way, while linked lists store elements in a doubly linked list, like I showed earlier, with the two references one to the previous node and one to the following node, right? Also, for data manipulation, the array list is slower. So all bits all bits in an array are shifted in memory every time you are taking out an element or putting in an element. You have to shift the entire array. While it's dynamic, it is a bit slower because of that. Where linked list, you don't have to do that. You don't have to shift the entire array whenever you insert an array. Whenever you insert an element inside the linked list. Okay. Now, the array list class acts only as a list and it only implements the list interface, while linked list class acts as a list and a queue, and it implements the list and dequeue interfaces, which is a double-ended queue, and you can add and insert elements from both sides. So which one is better at what instance? Well, an array list is great for storing and accessing data. It's a lot faster for these type of things. If you want to traverse through either one, it's definitely going to be faster to traverse through an array list. A linked list is going to be a lot better if you're going to be manipulating data all the time. If you're going to be constantly inserting and deleting nodes, you want to use a linked list. You don't want to use an array list because of what I mentioned earlier, how it shifts every time you have to insert or delete something. You have to shift the entire array. If you put something at element index number 3, you have to shift the entire array. So, and that's time consuming. So those are the pros and cons and the differences between linked lists and array lists. Okay, so what I'm going to do with linked lists today, or what I'm going to show you what to do with a linked list. I'm going to show you how to add elements to a linked list. I'm going to show you how to remove elements from a linked list. Third, I'm going to show you how to find elements in a linked list. I'm also going to show you how to get the number of elements in a linked list and how to get and set elements from a linked list.